Hi students, welcome back to my Space YouTube channel. In this class, I am going to explain here remaining 3 questions. Question number 5, 6 and 7. First 4 question already we have done in exercise 8.1. In question number 5, in a parallelogram ABCD, E and F are the midpoint. ABCD is a parallelogram, E and F are midpoint of these sides. Then show that the line segment AF and EC trisect the diagonal BD, which means we have to prove that this BQ is equal to QP is equal to PD. These three parts are equal. Let us solve this. Since ABCD is a parallelogram, ABCD is a parallelogram that is given. Then we know that in a parallelogram, opposite sides are parallel and equal. AB is equal to CD and AB parallel to CD. Since we know that it is given that E is the midpoint of the side AB, then we can say AE is equal to half of AB, and like that F is the midpoint of CD. Therefore, we can say CF is equal to half of CD. Therefore, we will get this AE and CF are equal and parallel. AE is equal to FE because AB is equal to CD. If we take this quadrilateral AECF, opposite sides are parallel and equal. Therefore, we can say AECF is a parallelogram. EC parallel to F. This, if it is a parallelogram, we can say AF is equal to EC because this is a parallelogram. EC parallel to F. Then we are taking in triangle DQC, this triangle DQC, F is the midpoint of DC and FP, if it is a midpoint and this is parallel to the third side in this triangle, we know that FP bisect this QD. P is the midpoint of DQ. Therefore, we will get DP is equal to PQ. First, we are taking this triangle. By using the midpoint theorem, if this both will be parallel, and this here we will get DP is equal to PQ. That is one. Similarly, we are taking the other triangle BAP, this triangle, only this part, this triangle BAP. E is the midpoint of AB and EQ parallel to AP. E is the midpoint, and this we are drawing a line segment which is parallel to the third side of the triangle. He is passing through the midpoint of the other side of the triangle, which means Q is the midpoint of the side PP, which means BQ and QP are equal. In first triangle we got this and this are equal. In second triangle we have got this and this are equal, which means these three parts are equal. BQ is equal to BQ, that is 2. From 1 and 2 we have got these three parts. BQ is equal to QP is equal to PD. Now let us go to the question number 6. In question number 6, show that the line segment joining the midpoint of the opposite side of a quadrilateral bisect each other. A simple quadrilateral is given. It is not given that it is a rectangle or square. It is a simple quadrilateral. Joining the midpoint of the sides. Here let's mark this. M is the midpoint of CD, M, and N is the midpoint of AB. We joined MN like that. X is the midpoint of AD and Y is the midpoint of BC. Then we have to prove that this line segment bisect each other, which means the point of intersection is O. XO and OY are equal, like that ON and OM are equal. Let us prove this. To show that, here we have to prove OX is equal to OY and ON and OM are equal. Here we have to do some construction. First let us join this. XM and XN, NY, and now look here, this is a quadrilateral X, N, Y, M. If we can prove that this quadrilateral X, N, Y, M is a parallelogram, we can easily say that OX is equal to this and this are equal, and these are, because these are diagonals of this quadrilateral. If it is a parallelogram, we can say the diagonals of the parallelogram bisect each other. So here we need to prove that only this is a parallelogram. Then we can say the diagonals of the parallelogram bisect each other. Here we are doing one more construction, joining AC. Then we are taking in triangle ACD, this triangle, we know that X and M are midpoint of the side of this triangle AD and CM. If we join this midpoint of these two sides of a triangle, the line segment will be parallel to the third side AC and half of AC. By the midpoint theorem, XM is equal to half of the third side AC and XM parallel to AC. That is one. Then we are taking the other triangle ABC, this triangle ABC. N and Y are midpoint of the sides of the triangle. By using midpoint theorem, NY is equal to half of AC and NY parallel to AC, that is 2 by midpoint theorem. We have learned midpoint theorem very clearly. From this 1 and 2, we can say XM is equal to x sum is equal to ny. These both are equal because x sum is half of AC as well as ny is half of AC, which means these both are equal and parallel. X sum is equal to ny and x sum parallel to ny. In a quadrilateral, if one pair of opposite sides are parallel and equal, we can say this quadrilateral is a parallelogram. Now we have got this quadrilateral is a parallelogram. X, N, Y, M is a parallelogram. In a parallelogram, we know that in a parallelogram, diagonals bisect each other, which means OX and OM are equal as well as ON and OM are equal. Now we have proved that the line segment join the midpoint of the opposite side of a quadrilateral bisect. Question number 6 is completed. Next, let us do the last question of this exercise 8.2, question number 7. In question number 7, ABCD is a triangle right angled at C. A line through the midpoint M is the midpoint of AB and MD parallel to CD. Then prove that D is the midpoint of AC. D is the midpoint of AC. Second, you have to prove MD perpendicular to AC. And third one, CM this distance CM is equal to MA is equal to half of AB. Let's prove first one. D is the midpoint of AC. In triangle ACB, it is given that M is the midpoint of AB and MD parallel to the third side BC. Therefore, by using the midpoint theorem, we will get D is the midpoint. By using midpoint theorem, we will get easily this answer. D is the midpoint. Then second part, MD perpendicular to AC. Here we have to prove this angle is 90 degree. Since MD parallel to CM, that is given MD parallel to CB, angle ACB, this angle is equal to this angle. If this both are parallel, we can say this angle and this angle are corresponding angle when it is a transversal line, which means this angle and this are equal angles. This is already given 90 degree, which means this angle also 90 degree. Angle ACB is equal to angle ADM is equal to 90 degree, which means MD perpendicular to AC. Second part also completed. Then let us go to the third part, CM. Here we have done a construction joining M and C. CM is equal to MA. CM and this are equal, and this is equal to half of AB. The third part we have to prove CM and MA are equal as well as this is equal to half of AB. For proving this, we are taking this triangle ADM, these two triangles ADM and this angle. These two triangles we are taking this and this, ADM and CDM. In this both triangle, AD is equal to CD. AD and CD are equal because D is the midpoint of AC. DM is equal to DM. DM is common. And angle, this both angle, this angle, and if it is 90 degree, this angle also 90 degree, which means these both angles are 90 degree equal. ADM is equal to CDM is equal to 90 degree, which means these two triangles are congruent. If these two triangles are congruent, we can say CM is equal to AM by corresponding sides of the congruent triangle. CM is equal to MA. Since M is the midpoint of, it is given that M is the midpoint of AB, which means M is equal to half of AB. Here we have proved this. CM is equal to MA is equal to half of AB. Okay students, this exercise 8.2 is completed. Please subscribe this channel. You will get all exercise, their answers and explanation in detail. Thank you for watching MathsWiz YouTube channel.